Hello, welcome to Taxonomy Online Mathematics. We are still on the application of percent differentiation, and here we are picking linear kinematics, the branch of mathematics that deals with what? The motion of particles in a straight line. So here you say linear kinematics deals with motion in a straight line. So if you consider a particle which is moving in a straight line such that its displacement from here to here, displacement, distance, its displacement from a fixed point is s. We are using s to represent the displacement. It could be d, it could also be h after a time t. So the velocity is the change of displacement with respect to what? T. Remember, the rate of change of one quantity compared to another is the differentiation, right? So that is going to be v equals to ds dt. Meaning if you differentiate a distance, a displacement with respect to time, you'll be having velocity. Remember your physics lesson. So velocity is what? Displacement over time. So if you find the rate of change on the distance divided by time, you'll be referring to the velocity. Alright. Now, if your velocity calculation gives you 0, it means that the body or the particle is at rest. The velocity, the displacement compared to time. Displacement. Before you can get 0, it means your displacement must be 0. If the time is 0, you might be getting undefined, right? So the displacement, meaning you are at a position, a rest place. You are not moving. So there will be no distance to cover. So in that case, your velocity, the displacement of the distance you have with time will be 0. Then if velocity is less than 0, meaning negative, then the particle is moving in the opposite direction. You know, when cars collide together, their velocity determines which direction the car is supposed to go. If two collide, they'll definitely move in one direction. So the velocity will be, if it is negative, it means you are moving in the opposite direction to the direction of the particle. All right. Then the acceleration, A, we use A to represent acceleration. It's also the rate of change of that velocity with respect to time. So the rate of change of velocity. You know, velocity is just about the speed. You have been talking about increase the speed or accelerate. You are only talking about the how many distance or kilometers you cover within a short possible of time. That is going to be the acceleration. So A is dv dt, the change in the velocity over the time. But already we know what the velocity is. It is also the change in distance over time. So if I have A, first differentiate the V, but I've already differentiated the V in the case of distance. So I can say that the acceleration is the second derivative of the distance, of the displacement. The second derivative. I can get this, or I get the second derivative of the distance or the displacement. All right. Then if A, the acceleration is 0, then the velocity of the particle is constant. Acceleration is 0, then the velocity is going to be constant. All right. Then if the acceleration is bigger than 0, meaning positive, the particle is accelerating, is moving, is have a motion. There is a motion. Then if the particle is less than 0, that's the acceleration. Negative values, meaning the particle or the body is slowing down, or the body is retarding, or it is what? Decelerating. So if you are reducing, you can also reduce or slow down to have a negative acceleration, or you have retardation of the acceleration. So these are the concepts that we are going to employ into linear kinematics. To make meaning from all this, let's take a question and apply the concept we just learned. All right, so let's look at it. So an example of kinematic question could be a particle moves in a straight line so that its distance from a fixed point O after a time t seconds is s meters. Then the s is given in as an equation in terms of t. We have to show that the particle is at rest. For the particle to be at rest, the velocity must be 0, right? So 2 different times and find those times. And hence find the acceleration of the particle at those times that we are going to find the beginning. So at rest simply means velocity. And velocity is not given, so we begin with our velocity, right? V is the differentiation of the d with respect to time, right? So 3 come forward to be 3 times 1, 3, divided by 3, 1. Then t, 3 minus 1 will give us t squared. 2 also come forward to become 6, 6 divided by 2, 3 times 1 as a negative, so negative 3. Then t power reduced by 1 plus this become 2. So in this case, we have our v, but we are saying v is 0 because at rest. So the particle at rest means v is equal to what? 0. That simply means the whole of this, as in t squared, 3t plus 2 should give us what? 0. This is a quadratic equation, right? We find factors of 2. When you add, you get minus 3. As long as this is minus and this is positive, the two factors must be negative in order to get a negative number here. So I'll be having negative 1 times negative 2. That will be positive 2. The sum of that will give you negative 3. So open bracket t minus 1, open bracket t minus 2 equals to 0. So here, this is equal to 0 or this, meaning the t will be 1 or what? 2. The t, we are asked to find where the bodies are read at 2 different what? Time. So these different times are going to be the 1 seconds and what? 2 seconds. So we only see that, therefore, the particle is at rest. We can say at or when t is what? 1 seconds. 1 second, right? And 2 seconds. All right. So what do we need next? We are now going to find the acceleration. So we know our acceleration A is also going to be the differentiation of V. So the V with respect to what? T. That make A equals to, where is it? 2 come forward, 2t, you subtract 1, it is gone, minus 3. So that will be 2t minus 3. If we differentiate this, you get 0. So now we are having our acceleration to be equal to 2t minus 3. Let's find the acceleration of the particle after these times. So now at which time? We are looking for the acceleration. So we can say that when t equals to which time? 1. Our acceleration is going to be 2, 1 minus 3, which will give you negative 1. You will see that? 2 minus 3, negative 1. Then, when t also equals to 2, the second one, your acceleration is going to be 2 times 2 minus 3. That will be 4 minus 3, right? That will be 1, positive 1. So now we are having, this is minus 1 and what? Positive 1. So now the next thing to think of is, and interpret the result. We have to interpret what this means and interpret what this means. We know this is going to be retardation. This is going to be acceleration. So let's do the interpretation. So for the first one, can say at A equals to minus 1 meter per second square. Are we dealing with meter? Okay, yeah, in meters. Then we can say that the particle is being retarded or decelerating or is slowing down. Then at A equals to 1 meter per second square, so that also means that the particle is accelerating, that is, it is speeding up. So remember, it said positive means acceleration, negative means retardation, or better still, slowing down. I guess the concept surrounding kinematics is okay. Don't forget to share with the required targets who will benefit from this tutorial. Like and leave a comment after watching.